All right, so we're gonna write a little sample program that demonstrates a priority queue of like to-do items. So imagine the way these to-do items are done is we're gonna use an extra class called a work order class because the elements in a priority queue must be comparable. And so here's a class that I've already written for you, but let's look at it called work order. The class work order implements comparable. It has two instance variables, a priority, which is an integer. And remember, the lower the value, the higher the priority. So priority one will be most important, priority seven, less important. Um, and then there's this description describing the task to be done. Okay. And this is going to be like your to-do list for like after school today. So we have a constructor where we can specify the priority and the description, and it initializes our instance variables. I wrote a toString method, so when we print it, it looks nice, and we can see both the priority and the description. And I had to implement the compare to method because I'm promising to implement the comparable interface. And so here's my compare to method where I need to return a value less than zero if this work order is a lower value than the other work order, meaning it's a higher priority, and I need to return a value greater than zero if this work order is of a greater value than the other work order, meaning it's a lower priority. And if they have the same priorities, I return zero. So I'm returning -1 here and 1 here, but like you don't have to do that. Any negative number would work. Any positive number would work. There's easier way, more concise ways to implement this, but I think this is the most straightforward. Question. That's a great question. I don't know. Let's find out. We'll try it. We'll like write code and try it. I don't know how it behaves. Huh. We'll find out in a moment. Yeah. Oh, that so it's certainly not it's not required, but it's definitely best practice. You are absolutely correct. So I should here put at override, and the override annotation is useful. Again, not required, but very useful because this is telling the Java compiler my intent. I intend that this method definition here is overriding a method from, in this case, comparable. And the reason why this is useful is, as an example, let's say I do override, but I misspell the method name. Now it generates an error. And it's like the method compare to is supposed to override or implement a super type method, and it's not. And I'm like, oh, you're right. I misspelled compare to. Um, or maybe I have my parameter type wrong. And it's like, yeah, you're not overriding the method. So that override annotation is super helpful to catch these types of errors. And these types of errors are a real pain to debug because like you run your code and everything runs and yet it's not working and you don't know why because it's just never calling your like overridden method. So excellent tip there for the override. All right, let's look priority queue and let's make your to-do list for after school today. So I'm going to assign this to a variable of type Q because there's no new methods here. We're just using the same Q methods we are using before, but the type of object I'm going to create here is not um, a linked list like it was before. Instead, I'm going to create a priority queue, and that's built into the Java standard library. All right, we're going to give you a bunch of chores and tasks to do after school today. So for each of these, we're going to call the add method. We're going to say new work order. And we're going to assign each thing a priority. So priority comes first. So a priority 3 is going to be to water the plants. Like it's good to do. We don't want them to die, but if it ends up being tomorrow, they'll survive. More stuff for you all to do. Work order. Priority 2 is to make dinner. Fantastic of you for making dinner. That's pretty important. Like you'll get hungry. More stuff. Priority two is walk the dog. Bad things can happen if you don't walk the dog. Oops, work order. Other stuff. Priority three, gonna shower because you had practice and we appreciate that. You might disagree with some of my priorities. You could change these. Priority nine, play video games. That's not that important. But like, it's an oops, work order. It's a nice break. Um, oh, and this one's important. We're gonna make this priority one. Work order. Priority one is take chapter 15 practice quiz. That's gonna actually be your homework for tomorrow, not for today. But that's important. We're gonna have our exam coming up here in a bit. Let's print this out so we can see what it looks like, because I honestly don't know. System out println queue. We'll print out the whole queue, priority queue, and see what that looks like. But now it's time for you to actually do all these things after school today. So we're going to use the same loop structure that we used in the queue demo program. We're going to say while queue.size is greater than 0. We're going to remove each item, and remove not only removes it from the queue, it also returns it. So we'll print it right away. And then before you run this, what I'd like you to do is predict the order in which these different tasks will be printed with this while loop. Then run it and see if your prediction is accurate. All right, I'm going to run it too. Oh, so here's the new thing I learned today. When we print a priority queue, it does print in priority order. That's cool. I wasn't sure what to expect. Wait, that's not true. It's not in priority order, right? It has the quiz is first, then water plants, then make dinner, then shower. It's like random, right? Ooh, okay. This is cool. So not priority order. This is a